Hi, welcome to Atomic Structure 2, Introducing Valence Electrons. My name is Dr. English. In this tutorial, we're going to be looking specifically at what are valence electrons, determining the number of valence electrons from electron configurations, drawing Bohr models for atoms and ions, and finally a little bit of practice at the end. So what are valence electrons? What do you need to know about them? The first thing that you should know is that when you look at a Bohr model of an atom, the outermost shell, or otherwise known as principal energy level, which is sometimes represented by a little n, is known as the valence shell. And the valence shell is where these valence electrons are located. So if you see down in this bullet down here, valence electrons are located in this valence shell. So you might ask, what's the point of a valence electron? Well, ultimately we're going to learn that valence electrons are involved in the formation of bonds. So if I look at this sulfur atom right here, and each of these dots is representing a valence electron, and here's hydrogen with its one valence electron, ultimately what we'll see is that these valence electrons will come together and form bonds. Determining the number of valence electrons from electron configurations. What do you need to do to figure out how many valence electrons you have? Well, it's very simple. All you have to do is look at the last number in the electron configuration for a given element, and that last number literally is the number of valence electrons for that atom. This is the general trend for groups 1 and 2, 13 through 18 on your periodic table. So let's look at a couple of examples. So the first one is cesium. And cesium has an electron configuration of 2, 8, 18, 18, 8, 1. So I look at this last number in the electron configuration, which is 1. Therefore, the number of valence electrons, 1. Let's look at aluminum. Aluminum is 2, 8, 3. Last number is 3. Therefore, 3 valence electrons. Antimony, Sb, is 2, 8, 18, 18, 5. So that last number is 5, therefore 5 valence electrons. And the last example that we have here, iodine, 2, 8, 18, 18, 7. The last number is 7, therefore 7 valence electrons. Those are a couple examples of looking at different electron configurations and figuring out how many valence electrons each configuration has. Now let's draw some Bohr models for atoms and ions and use the electron configurations to identify where our valence electrons are. Let's start by looking at a magnesium atom. We know that if we look at our periodic table, magnesium will have 12 protons, and since this is an atom, and we know protons will equal electrons in an atom, I'm going to have 12 electrons. Therefore, my electron configuration must be composed of 12 electrons for this atom. So it'll be 2, 8, 2, with 2 valence electrons on the outermost shell. If we were to draw the Bohr model for a magnesium atom, we'd say, all right, protons is 12, and I know that neutrons is 12, and therefore that is my nucleus. And then if I look at my electron configuration, I'm going to have 2 electrons in that first shell down here. I'm going to have 8 electrons in that second shell, so that's maxed out, so 2 here. And then finally in that third shell, I'm going to have my 2 valence electrons. So third shell right here. So these are right here, these are my valence electrons. So those are the electrons that would be involved in bonding. Now let's look at a magnesium ion. How many protons does a magnesium ion have? If you say 12, you're right. Now, it's an ion, and we remember, in an ion, protons are not going to equal electrons. In this case, I can look at my periodic table and see that magnesium has 1 charge associated with it. It's plus 2. Therefore, the number of electrons here will be 10. So the electron configuration for this one will be 2, 8. I've lost that outer valence shell. So when it becomes an ion for metals, which we'll ultimately learn when we get to periodic table, we're going to lose that outer valence shell and have an ion. If we were to draw the Bohr model for this magnesium ion, again, we'd have protons equaling 12, neutrons equaling 12, like so, and then still have 2 electrons and 8 electrons, and this is my first shell, and that's my second shell, but I've lost that outermost valence shell. I'd have to represent this as having a bracket here and a bracket here, an overall charge of +2. So the atom has its valence electrons with this metal magnesium, and my ion does not have the valence electrons. They have been removed. Now it's time for a little bit of practice. So draw Bohr model diagrams for each of the following atoms and ions in the space below. And while you're doing it, think about, where's my valence electrons? Does it even have the valence electrons? What's going on with it? So stop the video, do a little bit of practice, and check your work when you're done. Welcome back. Let's see how you did. We know that for a lithium atom, there's going to be 3 protons and 4 neutrons in my nucleus. And since it's an atom and I have 3 protons, I'm going to have 2 electrons in my first shell, and I'm going to have 1 electron in my second shell. And I know this is right because 2 + 1 = 3. And since I'm dealing with an atom, electrons will equal protons. So again, when I look at this, this is my valence shell right here. So this will have 1 valence electron. When I go over and I draw the lithium ion here, the number of protons stay the same, the number of neutrons stay the same. And then when I draw this, I'm just going to be drawing a 2 electrons, because this is Li plus or Li plus 1. The 1 is assumed. Then 1 shell. So now to say, hey, this is an ion, I'm going to put the whole thing in brackets and make this plus 1. So I've lost that valence shell. And again, that's going to become very important in the next couple of units that we do. Let's look at the oxygen atom. In an oxygen atom, we're going to have 8 protons and 8 neutrons. So that's my nucleus. And then it's going to have an electron configuration that involves 8 electrons. So I know that in my first shell, I can have a maximum of 2 electrons. So there's my first shell. And then in my second shell, I can have a maximum of 8, but really I only need to include 6, because 6 + 2 will give me 8, so that's my second shell. So if I look at the number of valence electrons for this particular oxygen atom, I would have 6 valence electrons. Now let's go to the ion. Ultimately, we're going to learn that oxygen is a nonmetal, and nonmetals like to gain electrons. That's why this oxygen atom here can gain 2 electrons and now get a full outer shell. If we go back here, we know that we are still going to have 8 protons, still have 8 neutrons, 8 protons, 8 neutrons, 2 electrons in the first shell. And now we're going to add 2 more electrons to the second shell, because it's an overall charge of -2, which means I have more electrons than protons. So 8 electrons here. Since I have more electrons than protons, when I put my brackets around this, I'm now going to have a charge of -2. So how many valence electrons do I have here? I've actually increased my number of valence electrons. I have 8 valence electrons because my original valence shell is still there, and now I've added to it. So what did we learn in this tutorial? Well, we went over what is the definition of a valence electron and basically what they do. We determined the number of valence electrons from electron configurations. We looked at drawing some Bohr models for atoms and ions and identifying valence electrons from there. And then we did some practice at the end. Need more help? Feel free to contact me. Have a great day.